So let's bring up Rouan.
Hello, hello.
Hello, how
How's it
are
going?
you?
I'm very well, thank you.
Well, actually, for us, it's quite okay. We don't have to do a lot because, yeah, you folks are doing all the work.
Excellent. So my first question is do you like pineapple pizza?
No.
No, that's a big no.
Because I don't hate myself.
No, and my Italian friends will kill me if I would say yes. That's the second thing. But like, I want to see more now. So, like, the floor is yours, Ron. Take it away.
Excellent. I'm afraid I do like pineapple pizza, so I'm sorry to my Italian friends, but that is unfortunately the reality. So my name is Rouan. I work for a company called Haven. They are based in the UK. I'm based in South Africa. I'm in sunny Cape Town today, and I'm very excited to be here talking to you about reviewing code for security issues. And the question we want to ask ourselves when we look at some code is we want to say, is this okay? And as an engineer, I found this was a little bit of a difficult question for me to start with. And I had to go through a little bit of a learning journey to figure out how to review code for potential security issues. So my plan today is just to share some tips and tricks with you. I've got 8 things that you can do when you're busy reviewing code to try and help you spot security issues. And so I guess let's hop straight in and we can have a look at some of those together. First thing to say, though, is that relying on code review for catching security issues is a little bit too much pressure. Code reviews are fantastic for catching issues, but they can't be the only thing. So within your organization, you want to make sure that you're building some awareness, that people know about security issues, know what potential issues might crop up, that you're doing some threat modeling. That's basically a process I'm sure you know already, but it's a process of identifying what assets you have, which ones are valuable to others, how they might try and get to them, and what you need to put in place to mitigate that happening. And then lastly, doing some penetration testing, and I'm sure other things too. But the key point here is it can't all rest on code review, even though I'll show you some good tricks. So the first trick I want to show you, the first tip, is to always pay attention to where the input is going. So there are a few questions you want to ask yourself when you're busy reviewing some code. And it's worth pointing out here that when we're saying reviewing code, it could look like a few different things. It could be you reviewing a pull request or a merge request from a team member. It could be you reviewing your own code when or before you open your own pull request. It could be you reviewing the code of a pair that you're busy working with. So all of this kind of applies. I don't know why my slides keep changing. So there are a few questions you want to ask yourself when you're busy looking at some new. So first of all, in a change set, is there any new input? Secondly, have we changed the way that the input is handled? Maybe we used to store it in a database, and now we store it in a database and send it on a message broker. Maybe where it's stored is another question that you want to ask. So it's possible that it was stored in one place before, and now we're storing it somewhere else as well. Maybe we used to pop it in the database. Maybe it now goes in the database and in the logs. And lastly, and this is quite an interesting question, is you've got to think about how it's used later. So if some data comes in, we've got some input from a user, we know we shouldn't trust that. We're storing it, but we know we're not using it for anything else. Oh, but maybe we are. And so these are the kinds of things that you want to keep an eye out for when you're busy reviewing code. I did a fantastic secure coding course through Stanford a couple of years ago. And the key message I got is that the main way that people get into your system is by tricking you to mix data with instructions. So the basic idea, the picture here is about kind of a little low-level memory trick to get you to have instructions in the part of the memory and that actually come from the data. And this mixing of data and code is also the reason we have things like cross-site scripting on websites. And so that's the thing to remember. Never trust data because someone might be tricking your system into using it as an instruction. Tip number 2 is, are the right AAA checks in place? So what is a AAA check? 1, authentication. So here we ask ourselves, have we checked the actor is who they say they are? So someone is trying to do something on your website or your app, whatever it is, we have to make sure that they are who they say they are. Second, have we checked that they're allowed to do this? And this is quite a common issue that creeps into things. You need to do some sort of permission checking. Just because someone is authenticated with your system doesn't mean that they're allowed to do everything that you have on offer. Maybe they're not allowed to delete a user if they're just someone who has a profile on your website, for example. And lastly, auditing. And auditing will be different based on your company, based on your team, based on your requirements. But generally, for certain kinds of actions, you want to make a note of what happened, essentially. So you want to pop something in your logs in your database to say, hey, something happened here. Let's keep track of who did it, when did they do it. Here's a little screenshot of a code change that's introducing an authorization-related vulnerability. So if you have a look here, we've got 3 endpoints where people can post a profile. There's a get, a put, and a post. This change request that we're looking at is adding the put endpoint. And what you can see here is that we're checking if they're logged in, we're checking if the profile is valid, and we're updating the profile. And that code looks fine when you're reviewing it most of the time. But the trick here is that we don't have another piece of middleware that we have on that post, which says user matches request. And so with the code as it stands here, we know that someone is logged in, we know that they are who they say they are, but we would allow them to update any other user's profile. And that's problematic. We don't want that. So you got to make sure that you got those 3 A's covered when you're reviewing some code. Third, have the assets changed? And this was an interesting one to me. I never thought about the assets in this way. So let's say we have a website and we're storing some sort of information about a user. Some kinds of information need to be treated differently to other kinds of information. So 2 examples of that are personal data and payment information. So some things, just the list is longer than this, but emails, health information, credit cards, racial or ethnic origin, political or religious info, all of these things need to be taken special care of. And so when a pull request comes across your desk, you should make sure that the shape of the data hasn't changed. Because if the shape of the data changes in a certain way, it might mean that we need to treat our data differently. So for example, maybe we never used to care about how secure our database was because we weren't storing anything that was particularly secure. But now all of a sudden we have user accounts and we have information that belongs to a person. So we need to make sure that we're cracking down on that more. Here's an example. Here's a pull request for our little profile website. Imagine an online dating profile website. And you can see a pull request here. We're adding some new fields. We're adding ideal date, sunset, stroll on the beach. We're adding sexual orientation, so we can match the right people with the right people. We're adding favorite color and favorite food, pizza with pineapple on it. But this change adds sexual orientation as a field. And sexual orientation is a protected piece of information in many parts of the world. In Europe, it's under what's called GDPR. And so what that means is there's this protected data. We have to take super special care of this data. We're not even allowed to keep this data unless we have a very good reason to do so and the consent of the user. And so that's always something to keep an eye out for. All right, the next thing that we want to look out for, number 4, is are you leaking data? So for this one, you want to try and think about whether you've got information that you are releasing to other people accidentally. And this happens more often than you might think. The most common example is that your API might be returning extra bits. So maybe you have information about a user, but you're returning more than the page is. Maybe there's a page, it wants to show a picture of the user and their name, but we're also returning their home address. Whoops, that's not great because then attackers can use that to get extra information about your customers. Second one that happens quite commonly is, are you logging stuff that you shouldn't? So maybe you're logging personal information, which isn't great because normally the kinds of protections that you put on your database to make sure that you're not leaking personal information are not the same ones that you put on your logs. Maybe you're logging something like a bearer token when an authentication request fails to a third party, and now you've got secrets in your logs. And a nice little trick to keep in mind to make sure that you're not leaking any data is to make sure that you don't keep anything that you don't need. If you don't have it, you can't leak it. Right. Here's a little trick as well. It's super helpful to make sure that your API stay a little bit more secure. You can see here that we've got a profile object, and what we're doing is we're pulling off the first name and the avatar URL from that, and we're sending that back to our client. Very simple, but in most cases, a lot of engineers will return the whole profile. And having this kind of allow list of fields that we want to send back to our clients is a very simple trick, keeps us nice and safe, and is a good thing to keep an eye out for when you're busy reviewing code. Okay, next one. Are there any new dependencies? And this is a particularly hot topic at the moment due to something called supply chain attacks. And so the idea is that someone is going to inject scary code into your application, but they're going to do it quite far away from your actual code. And dependencies are one way in which they can do this. So when you're looking at a new dependency, if a pull request comes across your desk and there is a new entry into a package.json or whatever package manager you're using, ask yourself, do a little bit of research. Is the library trusted? Is it popular? Is it well maintained? And lastly, do you really need it? Maybe you can do it with some plain code without a dependency at all. Here's an example of from a pull request that I opened up against an application, an open source library a number of years ago. And there was this is a JavaScript application, and you can see that there's a package that was there called net. And net is a built-in Node library. And so in your application, you can say import net from net, and it just works. You don't need a dependency for that. But somehow this is crept into the code. And net was a real package on NPM, didn't have a lot of information about it. There wasn't any code there really, it looked like. But you could see how that squatting on a name like that would allow someone to inject malicious code into your application. So I opened a pull request to remove it in this case, but this is a really great thing to keep an eye out for. You want to make sure that any new dependency is sound. Next up, has the config changed? Misconfiguration is a super common cause of security issues. That's probably an exaggeration, lots and lots and lots of the examples that you see in the news of information getting leaked, of security hacks, are due to misconfiguration. It's very, very easy to make a misconfiguration issue. You can see from the screenshot there, Microsoft had a bit of a whoopsie, and they lost 250 million customer service records due to just a checkbox on a database, really, right? Should this be secure, yes or no? Didn't tick the box. A really, really helpful trick here is to remember that if your config isn't code, you can't review it. So make a real effort to have your infrastructure defined as code, your configuration as code, because then changes to configuration can be reviewed. A couple of years ago, there were a lot of issues with people not securing their Amazon AWS S3 buckets. You can see that little red exclamation mark there saying that public access blocking is off. Whoops. Suddenly all of your customers' information is available to anyone who's clever enough to find it. Not great. Make sure that things are locked down. Number 7, this is our second last one. Ask yourself if anything is being cached. The reason this is really important is particularly when dealing with user-specific information. If your caching is wrong, you're going to show Susan's information to Tandor, and that is going to be a problem because you've cached it when Susan was busy looking at hers. It's really important that everyone in your organization, when they are reviewing pull requests and when they're writing code, understands the default cache behavior. And it's really helpful to have good cache keys as well. Number 8, this is the last trick. If you're short on time, if you don't have the time to look at everything in a pull request, the handy trick is to focus on where the data enters and leaves your systems. Check the borders. So if you're having a web request that you're dealing with, have a look at what data is coming in. When we put it into a database or put it on a queue, have a look at what data is leaving. Those are the 2 most important places to start when you're reviewing a code for security issues. I'm going to share a few tips really quickly that have helped me learn a lot about secure coding. The first thing is to find yourself a security mentor. Find someone who knows more about security than you do. Ask them questions, hear what they have to say, see who they follow on social media, and just try and get a bit closer to what's going on. Secondly, if at your company you have things called post-mortems, when there are security issues, turn up to those, learn about them, read the notes, see what went wrong, and see if you can learn from it. I also started listening to a podcast called Smashing Security. It's amazing. It's not a particularly technical podcast. It's just a very entertaining one. And people talk about all kinds of things that go wrong with, I don't know, smart fridges being hacked and things like that. And it's just kind of like a funny take and kind of gets you thinking about security. And the next one here is to offer help during pen tests. Pen tests can be difficult to organize at organizations. So it's really helpful if there's an engineer there saying, hey, I'm willing to help. I'm happy to help you talk to all the team leads and figure out what needs to be tested and when, because then you can kind of get close to the action. And lastly, find a good security course online. There are a few of them, maybe one specific to the language that you're coding in most of the time. All right. And a quick recap before I finish up. These are the 8 things you want to keep an eye on. Check your inputs. Make sure you got the right AAA checks. Check your asset type. Has it changed? Make sure you're not leaking any data that you shouldn't be leaking. Check the dependencies to make sure they're not dodgy. make sure your configuration is code, that there aren't any bad changes. Make sure that you understand your caching rules and that those are all okay and being respected, and that you're not going to leak one person's information to another one. And lastly, check those boundaries. Those are the main places where you want to have a look. So that's everything that I wanted to tell you today. If there's time, I'm happy to answer some questions. Otherwise, you can catch me online later.
Wow. Thanks. That was like super concise, super actionable, and very, very much to the point. I got some questions, or not basically not questions, but just remarks like great talk, useful advice. So people love it, and I think this is the benchmark of what a lightning talk should do. And if you put that in 15 minutes, I mean, great job, man. I appreciate
that's very kind of you to say.
This so much. So I am sure that when the video goes up, because we basically are recording everything, comes up, it will be a smasher and people will share it right away. First of all, I want to bring in my fellow sneak person. Well, basically, I have to be kind to him because he's my manager. Hi, Liran.
Hey everyone, what's up? It's amazing talk, Ron.
For the last part of this thing, you're taking over. So I would say Matt, Liran.
Yeah, I've got the better co-host now. So
oh, thank you. Thank you.
Have arrived.
Oh, I appreciate it.
Feels so much better now, right, Matt?
Hey, you know what? Bye.
Thank you, Brian, for all your help this morning. It's been awesome. And thank you, Rouan. We'll let you go if we need to move on, unfortunately. But if folks have questions for Rouan, I'm sure you can either get on the Discord, which I'll put on the screen again. Oh, no, that's the wrong one. It's this one. And or contact you offline. Right. And thank you again for your talk.